Ever wondered if a machine could write a poem that really moves you? Or paint a picture that just takes your breath away? Well, today we're going to explore that exact question. We're diving deep into the world of generative AI, and we'll be using David Foster's book, Generative Deep Learning, as our guide.
You know, for thousands of years, creating things was, well, it was our thing, a human thing. From the very first paintings on a cave wall to the most incredible symphonies, it was how we told our stories, how we made sense of the world. But what if that's not exclusively our domain anymore? I mean, can you actually teach a machine to be creative? Can an algorithm spit out something that's genuinely new, something that feels, well, human? That's the big, kind of wild question at the heart of generative AI. So let's see what the answer might be.
To really get how an AI learns to create, we've got to start with one foundational concept. And luckily, the book uses this fantastic analogy that just makes it all click. So let's start there.
Okay, so picture this. You're standing in front of a colossal, maybe even an infinite wardrobe. Your job is to organize every single piece of clothing you own inside of it. But there's one rule. Similar items have to be placed near each other. So all your denim jackets, they're going to cluster together over here. Your running shoes, they go over there. All your fancy formal wear gets its own little neighborhood.
This perfectly organized map of all your clothes, that's what researchers call latent space. It's basically just a compressed, simplified map of all your complex data. And this is where the magic happens. Your stylist, Brian, can now create a totally brand new, unique item of clothing just by picking an empty spot on this map. He doesn't need to copy an existing shirt, he just needs a coordinate in this, style space.
Okay, so an AI can map out existing styles. That's pretty cool. But how does it get so good at creating new things that you literally can't tell the difference from the real deal? Well, for that, you need a little competition.
Imagine you own a factory that makes a world-famous brand of toy bricks, but suddenly a counterfeiter starts flooding the market with fakes. To protect your company, you have to become a master detective, right? You're going to scrutinize every single brick, learning to spot the tiniest little imperfection that gives away a fake.
This whole setup, it perfectly explains how something called a generative adversarial network, or a GAN, works. It's basically a constant battle between two AIs. You've got one, the generator. That's the forger, and its only goal is to create perfect fakes. And then you have the other, the discriminator, who's the detective trying to spot them. Every time the detective gets better at spotting fakes, the forger is forced to get even better at making them. It's this relentless creative arms race, and the result is a generator that becomes so good at faking, it's not really faking anymore.
All right, now let's talk about the magic behind so many of those incredible AI image generators you're seeing everywhere now, like DALL-E or Midjourney. It's a process called diffusion, and believe it or not, it all starts with complete and total chaos.
Think about an old TV screen, one filled with nothing but that black and white static, just pure random noise. Now, what if you could teach a machine to look into that chaos and somehow find a hidden masterpiece inside it? That's the absolutely mind-bending idea behind diffusion models. They don't start with a blank canvas, they start with chaos and learn how to reverse it.
So the training process starts by showing the model a massive library of perfect, high-quality images. In this case, we're talking about thousands of different pictures of clothing. The whole goal is for the model to learn, down to the last pixel, what a correct shoe or shirt or handbag is supposed to look like.
Okay, now for the really wild part. The algorithm then takes all those perfect images and starts to systematically ruin them. It adds a layer of digital noise, and then another, until the original image is completely gone, lost in a sea of static. The AI's entire job is to just watch this process of destruction and learn, meticulously, how to reverse it, how to take a noisy image and figure out the exact step to make it just a little bit clearer.
So after doing this thousands upon thousands of times, the model becomes an absolute master at denoising. It's so good, in fact, that you can now give it a completely new patch of random static, pixels that have never been part of an image before, and it will confidently work backwards, engineering that chaos into a unique, coherent picture. It literally creates order out of chaos. So we've got these models that can navigate style space, models that learn through intense competition, and models that can literally create order out of chaos. This stuff isn't just a clever programming trick anymore. These are seriously powerful new tools. So what does it mean now that they're here? Let's take a look at the impact. The potential uses are just staggering. In the workplace, we're already seeing it act as a co-pilot for programmers, helping them write and debug code in seconds. It could totally revolutionize education with personalized tutors for every student. It's speeding up scientific discovery by predicting complex stuff that used to take years. And of course, it's unleashing totally new forms of art, music, and storytelling, giving that creative power to millions of people.
But as you can imagine, this incredible power also comes with some profound challenges. This technology is forcing all of us to confront some very, very difficult questions about truth, about ownership, and even about the nature of intelligence itself.
We have to remember how these models actually work. At the end of the day, they are incredibly sophisticated pattern matchers. They're just trained to predict the next most likely thing. They don't understand truth, and that can lead them to confidently invent facts, something people call hallucinating. This also raises huge questions about data consent, especially when it comes to training these models on the work of artists and writers. They're powerful tools, for sure, but they are not oracles.
You know, in the end, maybe the most profound thing about generative AI is that it's basically a mirror. It reflects back to us the vast ocean of human data we fed it, our language, our art, our ideas, and it leaves us with the ultimate question. Now that we have this incredible tool, what will we choose to create with it?